to make steel cables capable of holding up a bridge. Hello and welcome to Top Tech. This is the channel where we investigate the amazing technology that makes our world work. And today, we're focusing on something quite unique: the process of folding steel to make wire cables. In this video, we'll explain exactly how you take an ordinary steel wire and transform it into something that can hold up the astronomical weight of a bridge or an elevator. You might never have given these steel cables a second thought before, but they're pretty important. They carry you everywhere, in bridges, elevators, and arenas, so they need to be well made. Speaking of well made, if you enjoy our videos, help us carry this channel to new heights by smashing that blue like button. It helps immensely for the YouTube algorithm and allows us to continue making videos for your viewing pleasure. With that being said, make sure to stay tuned to the end. You'll never look past a steel cable again. What counts as a steel cable? First things first, let's just clarify what we mean by steel cable. We're not talking about the kind of wire you might buy in a homeware store. Instead, we mean industrial strength cables. And these cables differ from normal steel wire in two ways. One, they're really big. The smallest size is roughly 9 mm in diameter, and there's no maximum size. 2, they're made up of lots of different wires woven together. It's like the difference between a string, which is a single thread, and a rope, which is lots of strings drawn together. Why plant so many different wires together? Well, it makes the cables far more reliable. That's because the flaws in each of the individual wires are less critical, as the other wires easily take up the load. And while friction between the individual strands causes wear over the life of the rope, it also helps to compensate for minor failures in the short run. The strength of steel. Steel is a pretty great metal. It's an alloy of carbon and iron with a really high strength-to-weight ratio. Plus, alongside being really strong, steel is also ductile, meaning it's flexible and can bend without breaking. This makes it a great choice for wires that need to hold up heavy loads because you can trust it won't snap if the wire suffers a sudden shock, say the weight increases really quickly. And that brings us nicely to our next point. What are steel cables used for? There's a long list of uses for steel cables. The most obvious one is holding up heavy things. Think of the Golden Gate Bridge. But there's also stadium and arena roofs. Next time you go to a concert, look up. Giant observation wheels. Imagine a Ferris wheel at the fairground. It's all run by steel cables. Glass facade systems. When you're in a building with a glass front, it's probably held together with a web of steel cables underneath. Machines that lift and carry heavy loads. Cranes on a building site, for example, rely heavily on steel cables. Underwater cables for oil rigs and other vessels at sea. Cable cars, ski lifts, and aerial tramways. The steel cables do all the heavy lifting here. And the last and probably most common use for steel cables is in an elevator. Many of us probably depend on a steel cable just to get to our apartment or our office. The eventual use of the steel cable is important because it will dictate how the cable is made. Cables used on suspension bridges, for example, are called stationary ropes. They're mainly loaded by static and fluctuating tensile stresses. This means they need a specific pattern of weave in the cables, different from a track rope, the kind of fully locked cable used to carry a cable car. That's because these two types of rope have to deal with different forces. So, the manufacturing process for steel cables will change according to the eventual use of the cable, as we will see. It's all in the pattern. How do you get from raw steel to the huge, reliable cables that we need? Well, it's a complicated process which involves a lot of manual work. The first step is deciding the pattern of cable you need to use. When we talk about pattern, we mean the way the different steel threads are folded together. Some typical examples of patterns include ordinary. In an ordinary lay wire pattern, all the steel wires are the same size as each other. Seal. All wires are laid down parallel, but they are of different sizes. The number of wires in outer and inner layer is also the same. Warrington, W. In this pattern, the outer layer of wires has two different sizes, twice as many outer wires as inner wires. The patterns get more and more complicated and specialized depending on what you're producing a cable for. And, although it might sound odd, the patterns really matter. If you take two identical 6-strand steel cables, both 20 mm in diameter, both weighing in at 154 kilograms per 100 millimeters, and pattern them differently. One will be able to withstand a braking load of 25,900 kilograms, whereas the other will only be able to cope with 24,500 kilograms braking load. That's a difference of 1,400 kilograms just from the weaving pattern alone. The manual process. Shaping the steel into the pattern is a really tricky process, and it has to be done manually. Workers lock the steel strands into a vise and then twist them together according to the pattern they need. It takes a lot of strength to manage this. Often multiple workers have to hold the steel at once, especially for larger cables. And when it comes to finishing the cable off with a loop, workers bend the cable around curved blocks to create the shape that they need. What do you do with the ends? As with any piece of rope, the ends of a steel cable can fray quite quickly, so you need to find a way of securing it. The most common and useful type of end fitting for a wire rope is to turn the end back to form a loop. The loose end is then fixed back onto the wire rope, so it essentially comes back onto itself. Normally, to hold the loop in place, you would use a thimble. And no, we're not talking about the kind you would find at a sewing kit. A thimble can be installed inside the loop to prevent the cable from pinching or abrading as the pieces of cable move past each other. It's industry best practice to use a thimble, but there are some other ways to do it. You can use a wire rope clip, sometimes called a clamp, to fix the loose end of the loop back to the wire rope. Usually it takes 2 or more clips to terminate a wire rope depending on the diameter. As many as 8 may be needed for a 2-inch, 50.8mm diameter rope. The wire rope clip is not recommended by the US Navy and most regulatory bodies because they can become loosened over time if they're not periodically checked and retightened. The history of steel cables. Today, steel cables are pretty universal, but they were originally invented in Germany by a mining official named Wilhelm August Julius Albert in 1834. Up until that point, all mining haulage was done with hemp fiber rope or chains. But fiber ropes didn't last long in the damp conditions of a mine, so a bit of innovation was needed. So Wilhelm Albert invented Albert rope, as it came to be known, by hand winding strands of 3.5mm gauge wrought iron wires into a single weave. Interestingly, the process is not so different today. This rope saw a huge surge in popularity during the time of the gold rush. And by 1849, another German named John Roebling had set up a wire rope factory in 1849 in Trenton, New Jersey. From then on, steel cables were produced in the US on a grand scale, holding up the buildings and landmarks we know and love today. That's it for today's video. Now it's time to tie off any loose ends with a thimble maybe? If you enjoyed learning all about the big cables that move us everywhere, let us know in the comments below. And as always, make sure to like and subscribe. We'll be back soon to discuss some more amazing tech topics, so we'll see you then.